All right, class, today we're going to go to section 7.7. Now we're going to see that section 7.7 and 7.8 are a bunch of story problems. And we're going to go back to some strategies that we learned earlier in the book. One of them is specific ways to help us make let statements. And the other way is we're going to learn how to use charts again. And I know some of you like charts, some of you don't. But the idea with charts really organizes the data that we have from our story problem and just makes it much, much easier to put it together and solve. So as we look here then, 7.7 deals with mixture problems. Mixture problems are a big deal. Classic SAT question. So let's go back. What would happen if we were back in chapter 2 maybe? All right, and I had this. It said the sum of two numbers is 25. If one of the numbers is x, then what would our let statement be for the other number? Now, we did this back in chapter 3, I think, and we did some in chapter 4 and chapter 5. And it kind of goes back to, remember the story problem with the celery and the carrots, Mrs. Burton's favorite story problem? So if I'm looking at it that way then, what would my let statement have to be? If the sum of two numbers is 25, if one of them is x, what's my let statement for the other? Good job. It's got to be 25 minus x. Now, let's look at our second little reminder here. It says if 5 liters of water is evaporated from x liters of salt solution, the remaining solution is. Now, science people, evaporated. What's happening to water if it's evaporating? That's right, it's leaving. And again, so to get 5 liters of water evaporated from x, this would be x minus 5. Now, why is this a big deal? One of my famous sayings, order matters with subtraction. So just a couple little reminders. Now, as we start this idea of mixture problems, we're going to see that there's 3 different kinds. We have grocery problems. They're pretty easy and straightforward. We have chemistry problems, probably the easiest ones, and then investment or wages. They're kind of long and drawn out. So we're going to try and do 4 story problems, one of each, and we're going to see how to set them up and get the job done. So let's go ahead and look at our first story problem, okay? And again, this is going to be a grocery problem. It says the Somas Nut House sells a mixture of raisins and roasted nuts. Raisins sell for $4 a pound and nuts sell for $6 a pound. How many pounds of each should be mixed to make 40 pounds of a mixture worth $4.75? So it looks like we're going to Sprouts and we're going to the barrels and we're going to buy us some trail mix, but somebody made it. Okay, they made it before they put it in the barrel for us to buy. And so our question is, what are we trying to find? Well, they want to know how many pounds of each. That's what we're trying to find. Okay, that's the question. So we're back to the 5-step plan. So now that we know what we're looking for, step 1 is to define our variables. So let's come up with let statements. Now, since we're talking about raisins and nuts, guess how many let statements I need? 2. That's right. Now, I usually just take whoever's listed first as x. So I'm going to let x equal raisins, because that's who's listed first in my story problem. Now, if raisins is x, what are we going to do for roasted nuts? Okay, remember, I can't have 2 variables. Yes, did you see we're making a total of 40 pounds? So if raisins is x, then nuts has to be 40 minus x, and that's going to be nuts, okay? And again, I just wrote raisins and nuts, but remember, we're looking for pounds. Okay, so now that we've got our let statements, let's go down here and look at our chart. Now, the charts are already written on your test and quizzes, and they're already labeled, so I made that a little bit easier for you. So let's look here. If I'm filling in my chart, well, what's my number of pounds of raisins? Well, when we look at our let statement, we said raisins is x. Now, let's look at a story problem. How much do raisins sell for per pound? $4. Now I'm not going to put the decimals in because it's 4.00, so we really don't need it. If I look at nuts, okay, well, how do we find our numbers of pounds of nuts? Well, we go back and look at our let statements, and that was 40 minus X, and our price of nuts per pound is $6. Now, if we look at our mixture, what's our number of pounds? Well, remember it said we're going to mix to make 40 pounds. So we're going to make this a 40, and after we make our new trail mix, we're going to sell it for, and of the $4.75. Now, when we did these charts back in Chapter 3 and Chapter 4, how did we figure out the final column? What did we do to get the final column in the end of our chart? Good job, nice memory. We're going to multiply across. So this is going to be 4x. And then for the nuts, we've got $6 times 40 minus x. And then we've got 40 pounds, and we're going to sell it for $4.75. So row 1, we've got our let statements, we get our cost out. Row 2, we've got our let statement cost, and then we had to go back to the story problem to figure out the totals for the mixture. Now I'm going to go to the next screen, all right, and let's see how we put this together. Now, if you remember back in our previous chapter, when we go to do these story problems, after we've got all the data, all right, after we've got all the data put in our chart, okay, then we have to use our chart to come up with our story problem. And it always works out this way. Row 1, okay, plus row 2 is going to always equal row 3. So we're looking at the totals column at the end, and row 1 plus row 2 equals row 3. Or we could say the raisins, which is 4x, plus the roasted nuts, and there's my let statement for my roasted nuts, equals the total mixture that we're making. All right, so now we've got to go and do our algebra. So let's look and see what we need to do here. Well, 4x is going to stay where it is. We've got to take care of our distributive property. So 6 times 4 is 240 minus 6 times negative x, 6x. Now, anybody happen to know what 40 times 475 is? Good job, 190. Now, what do we need to do next? Yeah, we got to combine like terms. We've got 4x and negative 6x, which is negative 2x. We've still got that 240 equals 190. Ooh, who do we need to move to get x alone? Yeah, we're going to subtract 240 from both sides. And so now I've got negative 2x equals negative. Again, different signs, subtract and put the sign of the greater. Okay, what's x going to equal? Yeah, x has to equal 25. Now, we found x, but now we need to answer the question. What was the question? Well, if you remember, how many pounds of each? So, I'm going to write it over here. When we found x, that was raisins. Okay, and so if x is raisins, we know we have 25 pounds of raisins. And now, how many nuts? How many pounds of nuts do we have? Well, we've got to go back to our let statement, and that was 40 minus x, if you look up here. And so 40 minus 25 is 15. So I've got 15 pounds of nuts. Don't forget my check. The easiest way to check would be to add these, okay? And we've got 40 pounds, and that checks because it said we had a total of 40 pounds in our mixture. So that's my check. Okay, very nicely done. Now, let's move on and look at an investment problem. Now, investment problems are just long and drawn out. So when I look up here, it says an investor has $10,000 invested in 2 stocks. Okay, stock 1 pays 15% and the other 16%. And when he invests that $10,000, he gets a total income or total earnings, okay, of $1,520. And here's our question, okay? how much is invested in each. So if we're trying to figure out how much is invested in each, the first thing I need is my let statements. Well, what did he invest? Yeah, stock 1 and stock 2. So our let statements are going to define our variable. So I'm going to let X equal stock 1. I told you I just go in order with what was listed. I'm going to kind of remind myself that guy was at 15%. Now, what's going to be stock 2? What was the total amount of money he invested? Yeah, $10,000. So that means 10,000 minus X is going to be stock number 2. And I'm going to remind myself that one was at 16%. Does it make sense? Yeah, okay. So let's fill in what we know. Okay, stock 1 is, stock 1's rate is 15%. Amount invested is what we're trying to figure out. And now we know to get those totals, we're just going to multiply across the row. Now, whenever we're dealing with a percent, okay, whenever we're dealing with a percent, remember we have to change that to a decimal. So this is going to be 0.15 times X. How about stock number 2? Well, that's 16%. And again, when we look at my let statements, this is 10,000 minus X. And so again, I've got to change that percent to a decimal. So I've got 0.16 times 10,000 minus X. Told you, investments is long and drawn out. Now, if we're looking at the total investments rate, well, we've got 2 different rates here, so we're not going to really worry about something to put in there. What was our total amount invested? Well, we already know that was $10,000. And then what was our total earnings? How much did he make on his investment? Well, $1,520 was his total earnings from his investment. Okay, I need to go to the next line, but you've got yours filled in. Let me go ahead and put this up here so we have it to make our equation. And again, this was 16%, 10,000 minus X, and this was 15. Okay, so once again, when I go to get my equation, it's always going to be row 1, which this time was stock 1, plus row 2, the investments he made in stock 2, equals row 3, his total earnings. Okay, so let's see what happens when I put everything in the third column, the total column, together to make my equation. Well, stock 1 is 0.15x. Stock 2 is here. 10,000 minus X equals how much money he made on his stocks. Okay, so now I kind of need to take care of my distributive property here. So we've still got 0.15x. 0.16 times 10,000. Did you realize we got to get rid of 2 decimal places there? 2 zeros because of the 2 decimal places. Minus 0.16x equals 1,520. Now here's my question for you. We've got decimals. Now, in another section a couple days ago, we learned how to eliminate decimals. So my question is, would you want to deal with decimals or do you want to deal with zeros? Most of us would rather deal with zeros, so I'm going to go ahead and eliminate those decimals. I'm going to eliminate them, get rid of them, make the math a little bit easier for myself. And so we learn to do that. We're going to multiply by the greatest power of 10. So if you notice, both of these are in the hundredths place, so we're going to multiply by 100. So now let's go ahead and multiply everything by 100. And so we have 15x plus, now I'm going to have to add 2 zeros to that number, minus 16x equals, and if I multiply that, I got to add 2 zeros to the end. Okay, so now let's combine like terms. What's 15x minus 16x? Yep, negative x plus 160,000 equals 152,000. I've got to subtract 160,000. Now hopefully you realize they're different signs, and so I put the bigger one on top. And we're going to end up with x equals 8,000. Okay? Now, we found x, but what's the question? Well, we got to figure out how much he invested in each. So if stock 1 is x, we realize he invested $8,000 in stock 1. Stock 2, how do we find stock 2? Right, we got to go back to the let statement. What's 10,000 minus 8,000? That's going to be 2,000. So we just answered the question. And how do I check it? Well, the easiest way, if I add his investments, we get $10,000. Great job. Now, let's go ahead. We're going to quickly look at a chemistry problem, all right? A chemist has 60 milliliters of a solution that's 70% acid. How much water should be added to make a solution that is 40% added? So when we look here and read through it, the question is how much water should be added? Okay, that's what we're looking for. That's what the question is. So step 1 is my let statement. So therefore, I'm just going to let x equal the milliliters of water added, because that's what they're asking me for. Milliliters of water added. Okay, so when we're doing these chemistry problems, there's going to always be an original solution, a new solution, and we're going to always be dealing with water in the middle. Okay, but once again, your charts will be set up for you. Okay, so what's the original solution? Well, when I read that first sentence, okay, we see that the chemist had 60 milliliters of a 70% solution. Okay, so we know I've got to change my percent to a decimal, so we're going to get 0.70 times 60. Now, total amount of water. Well, that's what I'm trying to find, so that's where my x is going to go. Now, important question. What percentage of acid is water? Duh, there's no acid in water, so this is going to be a 0, so that kind of makes this line 0. Now, my new solution, well, we're trying to figure out the total amount. Now, remember, water was added, and we started with 60, so that has to be 60 plus x. What's our new percent acid? 40%. And once again, we're going to change that percent to a decimal and multiply across. Everybody understand? Good job. Okay, so let's go ahead and go to get the math done. I'm going to go ahead and put just the totals in here. This was times 60, this was 0, and this was 0.4 times 60 plus x. Now, once again, it's going to be the original solution, row 1, plus the water that we added, which was row 2, equals my new solution, which is row 3. So, what was our original solution? 0.7 times 60, water, 0, equals 0.4 times, that's my new solution. So we got to take care of our distributed property. Well, what's 0.7 times 60? 42. I'm not going to worry about that plus 0 because anything plus 0 is itself. And now 0.4 times 60. 0.4 times 60 is 24 plus 0.4x. Now, I'm going to go ahead and get rid of my decimal. So I'm going to multiply everything by 10. My greatest tens place is there. So we've got 420 equals 240 plus 4x. I'm going to subtract 240, get rid of my floater. All right, and so that's going to give me 180 equals 4x. If we divide 180 by 4 on both sides, what are we going to get? X equals, good job, 45. So my answer is 45 milliliters of water added. Now, I think the math is a little bit easy, but the check is a little bit harder. If I look at the check, we're going to have I'm just going to write it up above. Makes it easier. So let's see what happens with my check. Okay, we've got 0.7 times 60 plus 0 equals, and now this is going to be 0.4 times 60 plus 45, 0.4 times 105. All right, 0.7 times 60, and this is 42, and I promise if you do the math over there, it's 42. So there's your check. Now, we're running out of time, but let's go ahead and look at the last one. We'll go ahead and get it set up. How many kilograms of water must be evaporated from an 85 kilogram of a 5% salt solution to produce a solution that is 35% salt? So what are we trying to solve? Yep, how many kilograms of water? Okay, did you notice I've got an original, we've got water in the middle, and a new. So if I look there at the original, what was my total amount? Well, it was 84 kilograms. Okay, what was my percent salt? 5%. We're going to change this to a decimal and multiply by 84. Water added. Actually, this time we're going to evaporate it. Okay, we talked about that at the beginning of class. So this is going to be X. Again, how much salt is a water, percent salt is a water solution? None. So the middle becomes 0. Now, because we evaporated water, this time this is going to be 84 minus X. Okay, our new percentage for the new solution is 35%. So we've got 0.35 times 84 minus X. Okay, very similar to the one we just did. Okay, except this time we're subtracting X. We're subtracting water because it was evaporated. All right, so row 1 plus row 2 equals row 3. So we've got 0.05x times 84 plus 0 equals 0.35 times 84 minus x. All right, and we're going to go ahead and finish the job here. All right, now I think I'm going to go ahead and get rid of my decimal. I'm going to multiply by 100, make life easier. Okay, so this is going to be 100 times 5, which gives me 5 times 84, which is 420. 100 times 0 is 0. This is going to make this 0.35, so now I've got 35 times that, which is going to give me 2,940 minus 35x. And now we've got to finish the job. I'm going to subtract 2,940. Okay, so I'm going to end up with negative 2520 equals negative 35x. And if I divide both sides by 35, we get x equals 72. So our answer is 72 kilograms of water evaporates. All right, so a nice example for each type of mixture problem, and you can start your homework.